In this video, we're going to talk about the graphs of the cosecant CSCX, which is 1 over sine of x. We're also going to talk about the secant function, SEC of x equals 1 over the cosine of x. So the reciprocal of cosine is the secant, and the reciprocal of sine is the cosecant. So these are the reciprocal, sometimes referred to as the reciprocal functions. So values you can't plug in for the cosecant, well, can't plug in where sine of x is equal to 0. Okay, so we have vertical asymptotes at x equal to k pi, where k is an integer. Okay. And the secant, where cosine is equal to 0, that's bad too. So that's another vertical asymptotes at odd multiples of pi over 2. So x equals 2k plus 1 pi over 2. So where k is an integer. Right? So what does this look like? All right, well, the way that, I go about graphing the cosecant, okay, so the cosecant, if I want to graph the cosecant, so y equals the cosecant of x, what I do is I first look at the sine curve, okay? So let's look at the sine curve first. All right, so I'm just going to draw a couple of periods here. So remember, we go from 0, pi, 2 pi, so there's one period, negative pi, and negative 2 pi, that's 2 periods there. Okay, so that's the sine graph. All right, that's the sine of x. Now, what do we know? This is 1 over the sine of x. So this is bad, right? Whenever sine of x is equal to 0, it's undefined. So those bad values occur at multiples of pi. So we know our graph for cosecant. So we know there's going to be vertical asymptotes here. Okay. Got to avoid those places. Right. Now, how do we graph cosecant? All right. So this is where it's kind of cool. Okay, so cosecant, right? We're reflecting here. So this value here, this is at pi over 2, comma 1, right? And it curves up just like this. And it follows these asymptotes here. Okay, so it just gets really close to asymptotes, but obviously it doesn't cross. Okay, so just like that. And then here. So really all it amounts to doing is figuring out where your vertical asymptotes are, and then figure out where the peaks and valleys are. Okay, so if it helps, draw your sine function that corresponds first, and then just do this little trick right here. Okay, so all these little curves right here. Okay, now they kind of look, these curves kind of look like parabolas, but I'm going to caution you, these are very different than parabolas. Okay, so like the way to show you that they're different than parabolas, like if I zoomed out like really far, what this would look like is kind of like this right here. Whereas a parabola may look more like this, right? Eventually that parabola is going, x is going as far to infinity this way as it's going to negative infinity that way. Whereas with the cosecant, you know, your x is stuck. You're stuck between 0 and pi here. So that's a very different curve than a parabola. So be careful. Don't say, you know, oh, I'm going to put a parabola here. Those aren't technically the same curves going on there. Okay, technically the definition of a parabola, maybe you learned this, maybe you didn't, but the parabola, basically you're taking a straight line, okay, called a directrix, and some point called a focus, and the parabola is a set of all points that is equal distant from those. Okay, so like here, this point, maybe that's 2, and that's also 2. So I know my picture didn't really line up there, so that wouldn't be a point on the parabola, right? So maybe this lines up a little bit better. Okay. So the parabola is the set of all points where you're equal distant. Okay. So very different, right? So that would be like a parabola, okay, like y equal x squared. That's very different, okay, than what we have going on up here. All right, cool. So that's the cosecant. Let's do the secant. So the secant x, remember this is 1 over cosine x. So what I'm going to do is the same thing, okay. First, I'm going to graph the cosine graph. So we start, go down, and we'll go back up, go down, we'll go back up. And so the cosine graph, this is like pi over 2, this is like pi, and then we got like 3 pi over 2, and that's like 2 pi there. So that's 0, 1 here, right? Negative pi over 2, and then negative pi, and so on. Okay, so what do we know? Well, once again, we've got vertical asymptotes where cosine is 0, okay? So I'm going to go ahead and draw in those vertical asymptotes. Why not, right? So all of my x-intercepts for cosine, that's where I'm having my vertical asymptotes. And that kind of gives me a clue as to where going with my secant curve, just like this. So if you're asked to graph the secant curve on the test, this is what I'm looking for, okay? I want you to determine where the asymptotes are, okay? So you tell me where the asymptotes are, x equal pi over 2, x equal negative pi over 2. Look, if you're having trouble like writing it out, kind of like what we did here, instead of writing that out, you could say, you know, like x equals k pi over 2, and then k is an odd integer. Okay, so you can get away with that if you want to say an odd integer there and then just put k just like that. Okay, so that's, I will take that. Or you could just say 2k plus 1 times pi over 2, where k is an integer. All right, so either one of those I will accept, okay? So, you know, whichever one's easier for you to remember. All right, those mean the same thing. All right, so really it amounts to finding those peaks and valleys. All right, so pi and negative 1 here, negative pi, negative 1 here, looks like 2 pi, or negative 2 pi and 1 there, and 2 pi and 1 here. Okay, so that's all there is to it. So that's y equals the secant of x. All right, so all we're doing is reciprocals. Okay, so maybe we should do, just a couple of practice problems. All right, just to make sure we've got this going on. So just to have our general form, y equals a cosecant omega x plus b, and y equals a secant omega x plus b. Let me move this over so I can get this all in one row. Right? So the role of a in these functions is to set the range. All right, so the range, so if you have a range here, the y value, okay, so like if you had this one here, the range would be y, okay, such that the absolute value of y is greater than or equal to the absolute value of a. Okay, so what do I mean by that? Okay, well, if you think about a sine curve, like if I had y equals 2 sine of x, okay, so it takes your sine curve, right, and what does it do? It gives it an amplitude of 2. Okay, how do you find your amplitude? The top minus the bottom divided by 2. So 2 minus negative 2 is 4, divided by 2 is 2. So that amplitude, that height there, is 2. How do I know? Look, whenever I plug this in, so this is like pi over 2 comma 2 here. Remember, whenever I go to draw my cosecant, well, what do? I start right here at this point, right? And then I do my asymptote. So it would make sense that this is related to that 2 there. Okay, so what this is saying is that I want y values that are bigger than 2. Okay, but what else do I want? I also want y values that are less than negative 2. Okay, so that's what's going on there. So bigger than or equal to 2 and less than or equal to 2. All right, so that's the idea there, what that A tells you, okay? And it all comes back to drawing that picture so you get a better idea, okay? So because the vertical stretch of the graph is by a factor of absolute value of A, all right? So just as the sine and the cosine function, the period, the period is 2 pi, right? So the period for secant and cosecant is also 2 pi. But whenever it's omega inside, okay, the period for both of these is 2 pi divided by omega, okay? So that horizontal compression of omega factor, okay, so that's where that dividing by the omega comes into play. Now the B is a vertical shift. Positive is up, negative is down, okay? All right. So let's do the graph of y equals 2 cosecant. Actually, let's do, since I just did 2, let's do 3 cosecant x minus 1. Okay, and then I want to use the graph to determine the domain and range. Okay, so want to use the graph to determine the domain and range. All right, so how I'm going to do this, okay, how I'm going to graph this, I'm going to start out, okay, thinking about the reciprocal, okay? So cosecant x is 1 over the sine of x. So I know I'm going to graph the sine. Now this is 3 cosecant. So I'm going to do 3 sine here, okay? Oh, I'm sorry, I just did the cosine. So sine, I'll try to do it a little bit better. So 3 sine kind of looks like that. Okay, so I have 0. Now the argument's not changed, so that's a period of 2 pi. Pi, 2 pi, gets me back full circle. Negative pi, and then negative 2 pi. Okay, and it keeps going, but you know we've got plenty here to work with. Okay, so what do I know? Well, every x-intercept becomes a vertical asymptote. Okay, hopefully you got that down by now. So I can draw vertical asymptotes at all my x-intercepts. All right, and now every peak and valley we're gonna take note of. Okay, so where are these at? This is pi over 2 comma not 1 but 3. Okay, go up to 3 and we go down to 3. That's what that amplitude here is doing. Okay, and then here this is 3 pi over 2 comma negative 3. Okay, move this, move that to right there. And this one is negative pi over 2 to negative 3. And then over here we got 2 pi, sorry, negative 3 pi over 2 to 3. All right, so my graph, all right, so this graph right here looks like this. Okay. But there's an issue. This is the graph of y equals 3 cosecant x. What do I want to graph? I want to graph this minus 1 added to it, okay? So how am I going to add on this minus 1 to everything? Well, what I'm going to do is I'm going to take and I'm going to shift everything down. I'm going to shift it all down 1. Okay, so shift it all down 1. So the graph of y equals 3 cosecant x minus 1. What does it become? All right, where are my critical points at? Well, I have one of them here at pi over 2 comma 2. So it goes up like this. Okay, let me make that a little bit better. Vertical asymptotes at pi. And then if I shift this down 1, then that becomes from negative 3 to negative 4. So down here, I have 3 pi over 2 comma negative 4. All right. Okay, same thing over here. So negative negative pi over 2 comma negative 4. My vertical asymptotes going on, that's a negative pi. And then this last one here, negative 3 pi over 2 to 2. Just like that. Okay, so we took each point and we shifted them down. Okay, so really the trick is just to figure out where those peaks and valleys are, and once you get all those points, then do your shifting. Okay. All right. The domain and the range for this graph. All right, the domain. Well, what values can I not have? Sometimes it's easier to get rid of the things you don't want than it is to write down the things that you do want, okay? So the domain is all real numbers, except what? Well, we can't have pi, can't have 0, can't have negative pi. So what values can we not have? Multiples, so integer multiples of pi. So to write this in set notation, it would be all x's such that x is not equal to k pi, where k is an integer. So that's the set theory, okay, for how you would say this. All right. The range. Now, you think about the range. Those are the y values, okay? What y values were okay to use? Well, everything up here and everything down there. So really, what are the cutoff points? So as long as y is what? As long as y is greater than or equal to 2, or y is less than or equal to negative 4 is the way I see it. Okay? So those are your values that are possible for this one. Okay? If you wrote this in interval notation, what would this look like? It would be negative infinity up to negative 4, bracket, union, and then 2 to positive infinity, just like this. Okay? All right, hopefully that will help you out. Sometimes these can be a little bit awkward to graph. I totally understand that. You know, if you're ever kind of stuck, you know, calculator is not a bad place to go. 1 divided by the sine of x, close it, enter, and then you can see, you kind of get an idea. Okay, so I think if you wanted to find a max or a min here, one thing that you could do is you could do secant calculate and find like a minimum and hit enter, and like left bound and then right bound, and then it tells you, okay, so that minimum there, so that minimum is 1.57, 0842, comma 1. So that 1.57, I think that's like pi over 2. Let's see here. Let's do that in a calculator. So, where's my pi button? Okay, secant pi divided by 2. Yeah, 1.57. Okay, so yeah, so everything works out how it's supposed to. Cool. All right, guys. Well, good luck in this section for graphing. Remember, like if you're changing your argument here, then that's going to change your period. And really all it amounts to is graphing your sine and cosine graph, and then finding the peaks and valleys and making your, I hate to say parabolas, but that's what a lot of people call them. Okay, so that making your little u's and n's to do those reciprocal functions. All right, good luck.